This is Sumas Rikenbam from National Institute of Technology, Manipur, presenting for the 12th Biennial National Conference of Physics Academy of Northeast. Today, I will be talking about the effect of size polydispersity on the static properties of ionic liquids, a molecular dynamics study. Ionic liquid is a liquid consisting entirely or almost entirely of ions. The credit for discovering ionic liquid is given to Paul Walden, this guy, for his discovery of ethyl ammonium nitrate, which is liquid at room temperature. An example of ionic liquid is given here, this ethyl ammonium nitrate. Unlike a well-known table salt here with sodium chloride NaCl, which is solid at room temperature, this sodium chloride is also made up of only ions, while this ionic liquid here in this beaker is liquid at the same temperature. This shows the contrast of between our traditional normal salt and the ionic liquids. Some well-known characteristics of ionic liquid are its low volatility, low vapor pressure, large electrochemical window, high thermal stability, to mention a few. It is sometimes called the designer's solvent for its ability to give unique properties by combining different ion pairs. Next, by polydispersed system, we understand it to be a system having variation in size of particles. And if there is no variation and all the particles are the same, then we call that monodispersed. Our polydispersed index is defined as standard deviation over mean times 100 in percent. But why are we considering ionic liquid to have polydispersed in size? This can arise due to mixing large number of ionic liquids. Mixers also offer the opportunity to fine-tune properties of the system. So we ask the question, what changes in the property will occur if the polydispersity is changed? In order to study this, we perform classical molecular dynamics simulation using lamps. We consider 2005 number of particles in which there are equal number of cations and anions. Between each particle, the potential is said to be Lennard-Jones and Coulombic potential combined, given by the expression here in the middle inside the box. The units are set in real units, and the size of cations are set in 5 angstrom, whereas the anion size is drawn from a normal distribution with mean 10 angstrom. That means that we have a polydispersity in the size of the anions. Here given in the figure on the top left or left top is the distribution of anion size for the polydispersity index 12. On the right side is a simulation snapshot of our system in the solid and liquid phases. The polydispersity index we are considering ranges from 0.3 up to 12%. Result analyzed include tracing of hysteresis loop by plotting enthalpy versus temperature, given in the figure left middle, and the left bottom we have the specific heat capacity versus temperature. In the enthalpy versus temperature, we see transition temperature marked here by T star C, which is a transition from liquid to solid, and transition from solid to liquid is marked here by T star H. That's the transition on heating. This transition temperature is confirmed by the plot of the specific capacity versus temperature. And this tracing of the heating and cooling curve, we call that hysteresis loop, and the loop area is calculated and plotted in the figure middle B. And from here, middle figure A and B in the middle, from the transition temperature, we see that increasing the polydispersity index decreases the transition temperature. This may be due to the increase in separation between ions, which is resulted from the increase in the polydispersed index, results in weaker Coulombic interaction, and hence the transition temperature decreases. Similarly, the hysteresis loop area also decreases on increasing our polydispersed index. Here, the spatial ordering is studied by plotting a radial distribution function. The radial distribution function is defined by this equation on the right, and here we plotted the anion and cation radial distribution function for both in liquid and solid phases. Here from these curves we see that on increasing the polydispersed index, or peaks for the radial distribution function shifted slightly to the left. So in summing this up, this result can be used to tune the transition temperature as well as hysteresis behavior, and it may be relevant for designing energy storage material based on phase change material. Lastly, I acknowledge NIT Manipur for the financial assistance. Thank you.